personally, I would love for like Ferrari and Porsche and all these companies to like just make make like a slight like offshoot company that is its own company, but it just makes the crazy stuff, and then you don't have the same rules.
Yeah, that's called Cosworth.
Hi everyone, welcome to the Car Chat podcast. I'm Sam Moores, and with me today I have Bruce Wood. Hello.
Good morning. Morning, Sam.
Good morning. Can you tell the listeners a sort of little short summary of who you are and what you do?
Sure. Thank you for having me on. So I'm Bruce Wood. I'm Managing Director at Cosworth. I'm sure on a podcast like this, people will know who Cosworth are. Maybe not know all of our history, but I won't go through all of that right now. But I started as a graduate, so in 1987, 37 years ago. My real passion was design, and I was lucky enough to get the opportunity to be kind of chief designer on some of our American race engines, and then moved kind of through the company, became technical director and ultimately managing director about 10 years ago.
And okay, where did this begin? How did this journey start for you? I know you've given a little explanation.
So I guess right back to when I was a kid, really. Although my parents weren't engineers, then my dad was very sort of enthusiastic model engineer. We had a little workshop in the garden shed, with a lathe and a little milling machine, and I became sort of very interested in that at a young age, and then probably at the point when I was 10, 11, 12, completely obsessed by that, spent my entire waking hours in there. So I kind of really enjoyed that kind of engineering, model engineering side of things, machinery from an early age, and then I always absolutely loved design. So I went on to do a mechanical engineering degree, and the thing that when I finished the degree, I say the thing that had sort of been if you like, a common thread through everything was saying this sort of love of engineering, but particularly around engines and particularly around design. So when I graduated, then I had two options. Actually, I was very keen to go and do industrial design and had an interview at the Royal College for a master's in industrial design.
Yeah. And
alongside that, I had the interview at Cosworth. And for me, fortunately, Cosworth offered me the job, and the Royal College didn't offer me a place. So the rest is history. But that kind of so I always had a real love of engineering and a real love of design. And I guess coming to Cosworth was, for me, and I think actually in common with a lot of people that have come here, wasn't about motor racing. It was about engineering. It was about sort of Cosworth being such a so strong in engineering, the fact that it was, and so strong in engines, the fact that their application was motor racing at the time was a kind of bonus, if you like. That wasn't what I came for. It was the engineering.
Yeah. And when you joined, I presume, well, no, I know technology has changed a lot, but what sort of projects were you working on at the start?
So when I first arrived, then Cosworth was just about to enter the Cosworth Sierra era, of course. So in '87, in motor racing, we our kind of most our biggest years in motor racing at that point were behind us. In fairness, sort of all through the '70s, obviously, with the points in the '70s where there'd be 22 cars on the grid and there'd be 2 Ferraris and 20 Cosworths. So that kind of that very big sort of mastery of Formula One was kind of behind us, and Formula One was becoming more the domain of the main car manufacturers. So Renault had come in, Porsche had come in, Honda had come in, Alfa Romeo had come in. And so that marketplace had moved completely away from us. So we were still there, of course, with Benetton. And when I arrived, to say we were just starting running the 1.5 litre turbo with Benetton. And Beatrice Formula One. But then, I say, very much sort of coming up very fast behind that was the emergence of the Cosworth Sierra, which was really concocted between Keith, Mike, Cosworth, and Ford for a way for Ford to celebrate the huge success they'd had in Formula One. Because although, obviously, there were sort of Cosworth engines, they were badged as Fords all through Formula One. Yeah. So Ford had a decade of Formula One championships behind them. The man in the street typically wouldn't really know it. So really that's how the Cosworth Sierra came about. It was a way of celebrating that decade of motor racing success and kind of taking that Ford-Cosworth relationship into the sort of public arena. And I guess with hindsight, it became iconic almost immediately in a way that I don't think anybody really imagined.
Yeah. Up until that point, had many or any companies like yourselves got their name on a production car? Because it became everyone knows the Cosworth association with that car. But presumably that was a big thing to try and get a manufacturer to do that.
It was a big thing, yeah. And I should say that, I was just arriving at the time, so
yeah.
I was in the middle of that.
Not involved.
But I think if you look around a similar time, a little bit later, maybe then from memory, I remember that I think was it Isuzu had kind of Dynamics by Lotus on the back of the cars, and I think Seat had Porsche, maybe engineered by Porsche was on the back of the cars. So I think the OEMs were kind of in a phase of wanting to kind of pull in some of those brands that maybe could elevate the positioning of the cars a little bit. So I think whether we were the first with Cosworth, I'm not sure, but it was certainly a thing that was sort of beginning to happen at that time, I think.
Yeah. And at that point in time, so are you working on, do you get given a certain part of an engine that you're then trying to work on, or how does it get sort of spliced down to what you ended up doing?
So Cosworth had a really strong graduate program at the time. We still have a really strong graduate program, but so you would come in, and so for the first year you would be rotated around different departments, and so you'd get to see a little bit of everything, and then you'd express a preference of what you'd like to do, and obviously it would depend very much what roles the company needed. I do remember very clearly that 6 of us with a graduate intake all rocked up on the same day, and kind of where we were going first was being divvied up, and somebody was going to design. I thought, I'd love that, and then somebody else was going to electronics, and somebody else was going to engine test, and it all sounded quite good. And then I have to admit, it came to me, and I was sent to Wellingborough, which was the manufacturing facility for the Cosworth Sierra, which was a different factory altogether, sort of 20 miles down the road, which was fine. But as my first day at the company and seeing my 5 colleagues sort of going into what everybody imagines as the kind of heartland of Cosworth, it felt a bit like I was ostracised for the first few months too. But again, a great learning experience. Learning very quickly.
Would any of those roles, like getting sort of bounced around a bit, I guess presumably in your head you were like, I particularly want to be in design or something, but did any of them surprise you in, you were like, actually this is way more interesting than I thought?
I think they were all really interesting. It definitely, I never faltered, I guess, in the kind of fact that throughout that I still wanted to end up in design. But I think the company was much smaller, and the opportunities that you got were just incredible. And again, this was 37 years ago, just at the beginning of electronic fuel injection coming into automotive generally and coming into racing. And again, I remember very clearly the Formula 3000 engine at the time. We'd just converted it to electronic injection from mechanical injection. and being sent off to a test at Snetterton and with I think with Onyx at the time, who were the Formula 3000 champions, and it's sort of like
Nice.
I was kind of like, yeah, it was definitely a baptism of fire. You were kind of thrown into stuff in a kind of like, go and sort that out, and it was like that in every department because so much was new and changing, and definitely right place at the right time. So there was lots of opportunities. Some of which were quite scary. I definitely felt completely out of my depth in some of those. But the company and also all the customers were hugely supportive through that. But some bits I definitely felt like, crikey, I'm out of my depth here. But again, that kind of all led me towards sort of at the end of that first year, then the opportunity to go into the design office.
Mm. And when you're designing stuff at that point in time, I presume there's no computational processing and all that sort of stuff. So technical drawings and theories. Do you then? Does that mean you have to end up doing a lot more testing? Because you're like, I just don't really know. We think this should work.
I think mainly what you see is the difference between sort of then and now, if you like. You see in the, particularly if you take modern Formula One, for example, in the reliability.
Right.
Back in the day, every race somebody would have an engine failure, 35 years ago. Whereas now it's absolutely unheard of, but extraordinary and completely comment worthy if somebody has an engine failure. It almost never happens. And I think that is that's the difference. It isn't really that we, there's only so much testing you can do. You've only got so many dynos, so many hours in a day. So I don't think we did sort of much more or much differently. But I think the biggest change was sort of really the arrival of finite element analysis and as you say, the whole computational side of it, which effectively just meant that the end result of doing the same thing was so much better, I would say. I don't think it made it quicker or particularly, but the end result from doing the same process of design and development, but throwing in that analytical part of it, you see enormously in the results of reliability.
And so what was your journey through the company up to managing director?
So after that first year, I went into the design office, which is kind of where I wanted to be. And again, you come in from university with great ambitions and pretty quickly, which again I think is probably a great learning experience. You're cut down to size, and I think the first thing I designed was a little rectangular aluminium cover, which was pretty much a little flat piece of aluminium with 4 holes in it. And but even that was a learning experience. From memory, I this was a little air gallery cover at the back of. So this was the HB engine. So it was our new Formula One engine for 89, from memory, the 3.5 litre new V8 that went into the Benetton and went on to be really successful. And it was a little flat aluminium cover for an air gallery at the back of the engine. And I remember quite clearly it was very close up to the gearbox. So the 4 holes, I put countersunk screws in those 4 holes. And then submitted it to be signed off, and it came back with a red cross through 3 of the. And it was pointed out to me that a countersunk screw effectively is like a dowel. It locates the plate that you're putting on as well as clamps it, and so you can only ever have one of them because otherwise they're fighting each other. So you can only have one countersunk screw, and the others need to be cap heads or button heads or whatever. And lessons like that, that was the first thing I drew and saying, you only had 4 holes and 3 of them are wrong, It's sort of, but that is such a great learning experience.
Yeah.
And so, as you can see, it sticks with me now. And so the company would build you up with things like that. But again, it was sort of the sky's the limit at the time. I really enjoyed it, and lots of people had some aptitude for it, and so. Within a year, kind of was designing the cylinder head for the Indy engine, the sort of early 90s IndyCar engine, which is the engine that then Nigel Mansell won the championship with in 93. So that was kind of my big break, I guess, if you like, in the design field, to be a sort of a big part of that XB IndyCar engine.
That must have been really cool. Even that first plate, when it gets signed off and you know that's going to get made, put on a Formula One car, and you can see it at the weekend on the TV.
Yeah, you'd be hard pressed to see my plate, but
well, yeah, unless something goes really wrong.
Since, like, sort of buried down in the. Yes, it is, absolutely. It was, and I think that's where. So I didn't come for the motor racing, and I think actually most people didn't. They came for the engineering. But motor racing is a great thing as an engineer, because you get to sort of test yourself every 2 weeks, if you so that was a real nice kind of bonus, if you like. Didn't expect that, but actually having a thing that, like, say, every 2 weeks you could kind of test yourself, and your scorecard was how well you did in the race, and then you go back and learn from that. And also, it's there's no escaping it. It's nice to be involved in a thing that has some public following. People would say, "Oh, motor racing, that must be interesting," in it. And I think most people would say it's nice to have something, nice to do something that people are interested in. So that, I think, turned out to be so I say definitely not why I came, but definitely motor racing turned out to be a nice thing, a nice bonus.
And presumably during your time at Cosworth, I guess it's a much bigger company now. Is it a much bigger company, or is it sort of flowed over the years?
It's ebbed and flowed, for sure. We're just shy of 380 people on this site now. In the last 20 years, I would say we've been as high as 500 and as low as 150. And so certainly in the racing years, absolutely you ebb and flow. Again, at the end of 94. So 94 in Formula One, we won the championship with Schumacher. Everybody sort of rightly thinks of as Michael Schumacher as in red for Ferrari, which obviously just changed the fortunes of Ferrari forever. But he started with Benetton, of course, and in 94 won the championship with the Cosworth engine. And at that time, Cosworth was riding high. We were pretty big, but some politics during the year, Ford sort of lost interest in Formula One, and then of course we did very well, and they regained interest. But by then Benetton had looked elsewhere and found the Renault engine. So when we started 95, we were with Sauber, and the results didn't come, and so that we went from sort of being on the crest of a wave, winning the championship, to overnight being much closer to the back of the grid, and that obviously ends up having an impact on the size the company can sustain and such like. So we've had, over the years of motor racing, we've had periods like that, which will be a big ebb and flow. In the last decade, which I'm sure we'll talk about a bit later, but the sort of what I call the hypercar years, we've had much more stability.
Yeah, that was going to be a question of. It's really cool to be involved in these, on the grid F1 every weekend. Wow. But yeah, it can change one year to the next, and you drastically go, oh, we need loads of people. Now we need none because no one wants an F1 engine off us. Has that been, during your time, a strategy? What sort of percentage has racing been sort of throughout Cosworth's life versus, I guess, up to now, really?
So I would sort of describe that we had kind of 5 phases, if you like. Company started in 58, and it was pretty much exclusively motor racing. We did an engine for Chevrolet somewhere in there, the Chevy Vega, which I actually saw in America just recently. It's one of those things that somehow is buried in our history, but But I don't think many of those were produced. I don't think it was a high point, shall we say? But Mike, if there's anybody out there that's got one and loves it, I apologise. I'm not trying to do a disservice. I just don't know much about it. But fundamentally, that first phase was all motor racing. and obviously the company kind of there is a Chevy wagon. Look at that.
I found it for the people on the internet.
I wonder how many were made. Perhaps somebody could find that out for you. But some, yeah. But
5,000 engines.
Oh, right, okay. That's
apparently 3,500 cars.
Yeah. What happened to the other 1,500 engines?
Yeah.
So they're still in stores. So fundamentally, that first phase from 58, when the company started, was motor racing, and the big break was 67 with the DFV, of course, with Jim Clark winning the first race at Zandvoort, which is a small aside. Only 3 times in history have we won as a new engine won its first race, so that demonstrates just how hard it is. And so that is the thing that transformed Cosworth from kind of, at the time, the company was in lockup in North London, so it was a kind of North London lockup became, major force, perhaps the major force in motor racing in the from the late 60s, and like I said earlier, there were points in the 70s where of 22 cars on the grid, 20 would be Cosworths, and that was a period, of course, where motor racing was sort of very different to what it is now. There weren't manufacturer teams, and so all the people that we think of as the kind of grandees of motor racing, your Williams and McLarens, they all started with a DFV in the back. So you had that phase, and then, again, as we mentioned earlier, in the 80s, the car manufacturers started to come in, and our market share went down, and that's where the Cosworth Sierra was invented. And that was phase 2, if you like. So phase 1 was motor racing. Phase 2 was the Cosworth Sierra. And for that 10 years, through the 90s, pretty much late 80s to late 90s, because you had the Sierra, the Sapphire, the Escort, then that was our primary business. The Sierra, Sapphire, Escort was significantly bigger business than the motor racing. And then that leads you kind of full circle back into motor racing. And the Ford era. So Ford then bought us in 97. At that time, if you call them, then Ford were taking Jaguar into Formula One. So Ford kind of went on this spending spree and bought Jaguar, Land Rover, Aston Martin, Volvo, and Cosworth. And the reason they bought Cosworth was to fulfill all of their motor racing. So we did all the Formula One engines for Jaguar and the other teams they supplied. We did all of the IndyCar engines in America. We did all of the World Rally Car engines. So they bought us in 97. And then that period lasted through to 2004. And not only were they our owners, but they were like 99% of our customer base.
Okay, yeah.
And so then when they sold us in 2004, along with Aston Martin and Jaguar Land Rover and Volvo, that was, if you like, the most difficult period, because, as I say, we had the people and the infrastructure. We were, say, a big company by then. We had, we've got 10 dynos, we've got 2 big machine shops, hundreds of people. So we had the infrastructure of a very well-established sort of motorsport Formula One company. But we had the work of a startup, we had.
And you only had one customer, which you don't have anymore.
Exactly. Yeah. So when they sold us, we had all that infrastructure, but no customers.
Yeah.
And then what I then described the next sort of 10 years, I sort of slightly tongue-in-cheek describe as the wilderness years, because we basically had to kind of try and reinvent ourselves and say, well, okay, what are we good at? Motor racing, I think one thing that did come to us is motor racing is kind of efficiency by any other description, really. It's like, at the time, might not necessarily be fuel efficiency, but specific power, and you're always trying to get the most performance for the weight, the lowest heat rejection. So all of these things play to efficiency. And obviously, beginning of the 2000s, the sort of mainstream world was becoming more and more geared towards that. So we were kind of in a reasonable place at a reasonable time, but nonetheless getting work to keep everybody busy was very difficult. And we really threw our net wide. I do remember one of the most slightly surreal things was we got a request from Siemens wind turbines if we could help them with fretting on the wind turbine bearings of one of their machines, and so went out to Denmark and were confronted by we used to like motor racing and little things like this.
Yeah.
And I remember this bearing was 1.2 meters diameter.
Oh, right, yes.
And we were kind of like, yeah, well, I like to think we provided them a little bit of help, but that was kind of, we were in this, it was consultancy, you're a gun for hire, and somebody looks up and says, we've got an engineering problem and you go and do what you can for it. So we certainly cast our net wide and certainly looked at some things that were very unusual for us in scale. But in the end, they're still engineering. The same principles exist. So I like to think we kind of made a success of that period in keeping the company intact and sort of ticking along. But it wasn't great. We didn't have the work to make it the sort of powerhouse, both sort of in terms of what we're delivering and which includes small profits these days, which wasn't necessarily the case in the wilderness years. So we suffered that wilderness period, and then now what I call the hypercar years. So we've had kind of motor racing, Cosworth Sierra, Ford ownership, wilderness years, and then the hypercar years. That's the kind of 5 phases that I break it into.
I'd like to dive back a little bit into that Ford ownership period of time. With this new influx of different, WRC, all of those things, did that produce some interesting opportunities? Did you get to go and do some cool stuff that was a bit different rather than going to a racetrack? Did you get to go out to some rallies and things like that?
I did, yeah, and I personally was very fortunate. I remember very clearly going to Monte Carlo, and so with Malcolm Wilson was the Ford Works team, of course, and again the whole rallying world relies on helicopters certainly did then. I guess they still do, but certainly
still does.
Yeah, and I do remember having the real just wonderful opportunity of Malcolm saying, go up with a helicopter, and absolutely amazing sort of following the cars with the helicopter, and again the pilot. It was like he'd trained in the Vietnam War. I mean, we'd just drop this thing down on a little patch of snow. And again, I remember actually at one point he just put it down on a sloping bit of snow, and then whilst we were there, you could feel it sliding backwards, and he just took off again. And sort of, so that was definitely quite a thrill. It was sort of just to see, and amazing, to see the rally right up in the very tops of the mountains where the sort of you couldn't normally get to without a helicopter and follow the rally through. So that was quite a. So even now, that remains quite a thrill to have been part of.
And what was your role during these windows? What position were you in?
So by the pretty much coincident with the beginning of the Ford years. So through the kind of I'd spent a long time in design, and I became kind of chief designer on the IndyCar program, which was CART at the time, Championship Auto Racing Teams, but essentially the American open wheel series. So I was chief designer on the XD engine, which raced from 96 to 2000, and just at that time, then the guy who was program director for all of the American series retired, and a bit earlier than anybody expected, and sort of again one of those moments in time where I was in the right place at the right time and decided to throw my hat into the ring and say, well, I know a lot about the engine, I know quite a bit about the racing, I'll do that. And so at the beginning of Ford's tenure, I took over as program director for the Champ Car or CART or IndyCar, whatever you like to call it, series, which was about about 70 people in this country, and then about another 50 in a facility we had in Torrance in California, where we were rebuilding the engines. And that was a fantastic time in championship auto racing teams. So it was when Mansell had gone over in the early 90s, and you had fantastic competition. You had Honda, Toyota, Mercedes, and ourselves as Ford all competing. It was incredibly strong competition. You had some great, really big names. Newman Haas was our works team, so we had Mario Andretti and Michael Andretti, and so obviously Mansell when he was there, and we had with a lot of big international names, and certainly many, many names that are more famous in America. But so sort of that's where I pretty much coincident with Ford buying us. I kind of stepped into that role, and then maybe midway through Ford's tenure, we had at that time we were sort of divided into. The company was very much divided into departments. So you had a Formula One department, which had all its own design team, all its own analysis and dynos. And so then you had the kart team, and then you had a smaller World Rally team. So you had three. And then you had an even smaller commercial division where we actually did an engine for Aprilia for the MotoGP series.
Oh, really?
So you had these four divisions.
All completely independent.
All sort of independent, really. And at some point in that Ford tenure, we sort of thought, well, that doesn't really, not very good for economies of scale.
Yeah.
And so I ended up bringing World Rally and commercial under my wing. So we then had just two departments, effectively. We had Formula One, which was its own department, and then we had sort of what became American Racing, World Rally, and commercial all in one department. So again, that was a great time. I'm going out to a couple of MotoGP races. This was something completely new again to me, and a huge learning experience. I do remember in the MotoGP thing, then all through our time in racing in America, then although people think of ovals, then ovals were less than half the series. The rest of it was permanent road courses or temporary street courses like Long Beach and Toronto and Vancouver. And so drivability was always a huge discussion with the drivers, and not least because those engines were only 2.65 litres capacity with a single huge turbo on the back. So they were 900 horsepower out of 2.65 litres.
Boost.
Sort of, yes, huge amounts of boost, and from a huge single turbo, which was the regulation. So drivability was this endless conversation. We did endless testing about this. And I do remember the thing that we sort of, if you want to improve the drivability, generally speaking, you end up exchanging that for peak power.
Right.
So if you want to kind of make a more drivable curve, you genuinely need to give away 10, 20 horsepower at the top or something.
Yeah.
And throughout all of these conversations with all of the drivers, we would say, okay, we can, we've got to give you this better curve. It'll be nicer to drive, and they'd drive it at a little Firebird. So, that's great. Yeah. And it's like, by the way, it does lose 20 horsepower, of course. And then they'd say, what? I'm not having that. Give me that. I'll take the 20 horsepower all day long.
Yeah.
And so we kind of came to think, well, you know what? It's we get this, but the answer is always in the end, give me the 20 horsepower. I'll deal with the drivability. So when we came to motorcycles, I think we sort of thought the same thing, and we made what I think was almost certainly the most powerful engine on the grid. But what we had underestimated, because we simply didn't know, is that drivability is one thing when you've got two enormous slick tires on the back of the thing and a contact patch. But when all you've got is a contact patch, the size of a couple of eggs, then it's a very different matter. And so we had to completely relearn that when the riders said it's undrivable, I need better rideability.
Yeah.
In the back of our minds was, well, you say that.
Yeah, you still want the top speed.
But you still want the top. Actually, they didn't. And actually, for the first time in our lives, here was somebody that absolutely would trade peak performance for better rideability. And so,
I don't know much about GP. But I know like a little bit about. I had a motocross bike when I was little. Not the same things, but it was a Revy 2-stroke, and everyone I feel like talks about these 2-stroke 500 cc's being like pretty savage to drive. Then going to 4-stroke, normally you get a bit more, quite a bit more torque. Does that not? Are you not sort of going? Yeah, they've got more challenging, but surely they're easier to drive.
Well, if I'm honest, I also I'm personally not actually a motorcyclist at all, so okay. I'm the last person to. But I know what you mean. Yeah, the certainly those 2-strokes were known for their
very peaky
savagery. Yeah. And so you would have thought going to but of course we'd gone from 500cc to 900cc, and at that time then, and so I don't really know anything about the 500 that came before, but at that point the F1 engine was revving to like 18,000. So yeah, I think from memory, now we didn't rev to that on the Aprilia, but I think from memory the engine was still something like 270 horsepower or something. Which I think was
a lot.
I believe was more than they'd come from with the 500. Yeah, so but yeah, that's so that was an interesting time.
That point of you saying Aprilia kind of wants to make their own engines, but they're like, we need an engine now. We'll come to Cosworth. Over the years, it seems to me like most manufacturers kind of want to be like, well, we make our engines. And then that's sort of in racing, that's kind of changed a bit, as you're saying, early periods, companies like Cosworth, other people making engines. Then the manufacturers kind of want to be like, we did it, even though when Ford owned you, it was basically Ford doing it. How has that evolved in time? So are most manufacturers just like, we make our own engines now? Or it seems like for special projects or one-offs and stuff, people like yourselves come in?
So I think they have morphed into two different things. I think, as you say, in motor racing, it absolutely used to be the case that that specialists like ourselves and Ilmore and Judd Engine Developments and other people, AER, over the years would do engines which would be badged by the major OEMs. That sort of changed really, I would say, again, at the kind of very, very end of the 90s, probably, when I think OEMs spending more and more money in motor racing kind of really felt like, well, to kind of get the value out of this, to get the credibility out of it, we really have to do this ourselves. It isn't the message we want to send, that we're going to spend hundreds of millions, but actually that's, as the manufacturer, that's our main part of it, spending hundreds of millions. Somebody else is doing the. So I think
doing this work,
that sort of changed. Yeah, that changed there, and we kind of learnt with Williams and Toyota. So when we entered the wilderness years, sort of 2004, our owners, who are actually been absolutely fabulous, still same owners after 20 years. Luckily, they have deep pockets, and they recognised that through no fault of our own, we didn't have any work to do.
Yeah.
So they funded doing the thing that we knew we could do, which was motor racing. So they funded the Cosworth Sierra engine, which went into Williams in 2006. So that was the year of the 2.4 litre V8s.
Mm.
And that engine was very good. Initially, the first race of the season, when everybody rocked up with their V8s, I think the pit lane would generally say we were as good as anybody. We were powerful, we were light, we were. Obviously, as the season went on, then that changed, because this was back in the time when you could do different development for every race and change them.
Yeah, so spend as much as you like.
So your Ferraris and all of these people were spending as much as they liked to get the reward of, and obviously our ownership, it wasn't realistic to just spend money like there's no tomorrow with it. So sort of by the end of the season, so we started, I think we were very equal, but by the end of the season we'd faded away a little bit. But But in 2007, Toyota, Williams left us for Toyota, and sort of became a bit of an open secret that actually at that point in time, obviously Toyota did a fabulous job over the years developing the engine, but at that point in time they were new to it, and I think sort of the general feeling that the Toyota was less powerful than us, certainly no more powerful than us, and was more expensive to buy, and yet Williams still went with Toyota. And we kind of thought then, well, hang on, if you've got a better product and it's cheaper but you can't sell it, that isn't a business. And fundamentally, it's the sponsorship thing. And we have no issue with this. I think this is right for Formula One. It's, for Formula One to grow, it needs money, and that needs to come from sponsors. So of course, you have a Toyota engine. There are many companies, and I think it was Epson, I think was the big one, and the printers that want an association with Toyota. So if you've got this mobile billboard which says Toyota on a big, airbox, then Epson will come along and say, yeah, we'd like our name next to that.
Yeah.
But understandably, Epson aren't interested in having their name next to Cosworth. That's meaningless. Yeah. So, you want to sell, a billion printers, or
that's interesting.
So really, Williams' decision to go to Toyota was driven by the kind of commercial sponsorship opportunities that it could bring. And I hats off to them. That's what they should have done. That's what they did do.
It's going to cost us more, but we can bring in more.
Yeah, exactly. Win-win. So absolutely. And that for us was a really great lesson, hard learned, but a great lesson to say, okay, this is, there isn't a place for an independent like us in Formula One. And that, I think, is we've no problem with that. I think that is right. So I think the manufacturers need to do the work themselves to get the kudos of doing well. And to say that the associations of different brands in that kind of big billion-dollar companies is again a very key part of what's brought so much success and size to the series. So
that's interesting. I'd never thought about that. But like up to current now, we basically have manufacturers making engines. Apart from now, we have Red Bull, Powertrains. Presumably, they're going to run into the same issue, or they might do. Red Bull's a pretty cool company, pretty big, good history and whatnot.
So I think the difficulty. So Red Bull sort of Powertrains, although ultimately, or Red Bull ultimately as a drinks company, I guess that's simply not how sort of I think anybody sees them or how they operate. So when we were there, we were an independent. We're a little company owned by two individuals turning over, 30, 40 million in a year if we're lucky, kind of thing. So, for us, there is no objective in being there other than to be able to make a profit. So for Red Bull, there is the sole objective of being there is to reinforce the image and the aura around Red Bull, the drink.
Red Bull,
So Red Bull Powertrains isn't in the position that they're kind of saying, well, hang on, we've got better product and it's cheaper.
True, it's different. Yeah,
they are part of the. We were trying to be a profit center. They're trying to be a cost center. Within the confines, obviously, of now cost caps and things, but fundamentally, it's they're not trying to make a profit out of it as a business. They are part of the enormous marketing machine for drinks.
So you have this very challenging period of time, which presumably must have been very tempting to be like, maybe I should go work somewhere else.
Actually, never really, to be honest. It was, I think, without seeming to sound too trite, then there's no escaping that Cosworth is a great place to work, and it I know people say this about, but it does become a second family, and so it was a tough period, but I think really, other than some people who were here, as I described, I didn't come for racing, I came for the engineering. I think that was most people. Some people absolutely were here for the motor racing, and so in that period, some of those people moved on, became super successful at Mercedes and the other manufacturers. So so yeah, but it was definitely a difficult period.
And then, so you were program director for these variety of teams and stuff, and then you moved up, I guess, up across. I don't know. Technical director, is that up? Is that overall?
Yeah, hard to say really. Again, we were sort of moving out of this. The company was reorganizing, I guess, because we'd had, say, these fundamentally two divisions of Formula One and then American Racing, World Rally, and Commercial Engineering. Well, we were out of all of those really. So it was no longer kind of appropriate to have kind of those different divisions, departments, if you like. So kind of everything then became morphed into just Cosworth, and so then I took on the role of technical director. So at that point, I was kind of looking after everything that wasn't manufacturing. So we had kind of two. Then the company was split more into two divisions, if you like, of sort of engineering, which encompassed design, development, analysis, testing, build, etc., and then manufacturing, which was the pure sort of, say, machining side of the business.
And as technical director, what sort of thing are you doing? Presumably, you're not necessarily sitting down and definitely not by this point, I'm sketching out drawings and stuff, or what are you involved in?
Only sometimes, to everybody else's irritation.
Yeah. Just a little black mark.
Yeah. So I'll leave it out. Yeah. But so so this was I guess 2010 maybe, and just beginning to enter the sort of hypercar years, which we sort of cited starting pretty much in 2014 really. But the thing that happened in 2010 and 2011 that gave us a little kind of future insight of how things could be was the Aston 177 and the Jaguar CX-75. And so if we rewind momentarily to what we were saying a minute ago, that in motor racing, the big car companies basically took all that in-house.
Yeah.
But for very specialist sort of road car projects, if anything, the opposite happened. They were keen on working with consultants, sort of independents like ourselves for that. And I think mainly because whereas motor racing is all about doing very small numbers and change, and road cars and production is all about typically big numbers, but primarily it's about not changing.
Yeah.
One thing that we've come on to it later, but one of the biggest transitions, most difficult transitions for Cosworth was understanding what production really is. Because when you're in motor racing, if an engineer pops up and says, I've got a great idea for making the engine better tomorrow, you'll turn the world on its head to do it. In production, if somebody rocks up and says, I've got a great idea for making the engine better tomorrow, so you can't do that. Don't touch it. Tomorrow's
That's for 3 years' time.
Tomorrow's one has to be identical to today's, which has to be identical to yesterday's.
And that has to work.
And that, you cannot change it. It's production. We've validated it. And that really is a big effort, a big car company thing. So I think a lot of what was happening was the big OEMs, that is so hard, production. They were so focused on production of their mainstream models that actually to try and do 100 off super specials was really hard for them, because that was not their systems. That's not how they were geared up. Their systems were geared up to production of thousands and all of the process that goes towards that. So if they actually wanted production of 100, they were quite keen to outsource that. So that started for us really as say with the 177, which I think was 2009, 2010, that came along. And that was great for us because that allowed us to use lots of the different facets of the company. So over the years, again, driven by motor racing, we'd become very sort of vertically integrated. We have everything on site. So, say obviously our own design analysis departments. So we've got 10 dynos, big machine. We've even got our own piston forge. We forge our own pistons. We machine our own cranks, cams, blocks, heads. So you've got this big infrastructure, and some of the problem with consultancy sort of business, if you back to the thing I described about the wind turbine bearing, that brings in some revenue for engineering and analysis. It doesn't bring in any revenue for the manufacturing side of the business. And so finding something that could utilize all of our facilities. When the 177 rocked up, we sort of thought, here's a thing. Because not only are we doing all the design and analysis, but we also manufactured the prototypes. We did all the testing in-house here. And then we ended up manufacturing the 77 production engines. And they all, left here, hot tested, and went straight to Gaydon to be installed in cars. So that was a little window for us on a kind of, actually, that's a really nice thing, because we use all the, we used our forge. We had Cosworth forged pistons. So we were able to utilize every part of the business. And so we did end up kind of thinking, there could be a nice business here.
This could be good.
But didn't really imagine it was going to, it could blossom into what it has. And then I guess the Jaguar CX-75 came on the back of that. And although obviously that never made it to production.
And what was the engine in that? Was it a hybrid?
So the engine in that, so when Jaguar first showed the car as a show car, it had two little Bladen jets, gas turbines, which were, so it was it was hybrid. They were going to charge the batteries, and it was going to be electrically powered. So I think with the best will in the world, that was a kind of show car thing that was never really going to. They didn't really intend to produce the car, but when they showed it, the public reaction to and it was, and for me remains,
it was cool.
A stunningly beautiful car. And the public reception was so positive that Jaguar thought, hey, we better make this. So we had, say in the past, obviously done the Formula One engine for them. And we'd had an association when we were both owned by Ford. So they came to us. And the original request was, we'd like a Formula One engine to go in the back of the car. And we kind of ended up saying, well, because by this
how
stage,
many mechanics do you want to take?
Formula One had moved into to V6 turbos, so we were in that era of them, and we kind of said, well, careful what you wish for, because do you really want that? They're revving at 13,000 RPM. Well, what gearbox are you going to use? How's that going to work? And as you say, they're very delicate. Or not delicate, they require a lot of support. So what we ended up doing is saying to Jaguar, what about we provide you an engine which is more suitable for the vehicle, but gives the same specific power as Formula One. And at the time, Formula One, our last Formula One engine was 313 brake horsepower per litre.
Whoa!
So we said, how about we do you a 313 brake horsepower per litre, so you've got that Formula One sort of halo tag that you can justifiably hang it on. This is the same specific power as Formula One. But what we ended up creating was a 1.6 litre turbocharged and supercharged 4-cylinder. Because again, what they wanted was in the car, 1,000 horsepower. They wanted 500 horsepower from the engine and 500 horsepower from electrification. And you might remember that if it had have happened, then that would have been the fourth of what became the sort of holy trinity, I guess. So you had the LaFerrari, the Porsche 918, and the McLaren P1, all of which were this new breed of more or less 1,000 horsepower or around there hybrids. And so Jaguar, their intention was to become that sort of fourth of those. And interestingly, I think if it had come to fruition, I do think Jaguar would have really been able to sort of boast about that, because whereas those other cars, obviously all of which have gone on to become hugely valuable and revered, then the hybrid element was relatively small.
Yeah.
I think they were all maybe 100 horsepower of hybridization. So maybe
Yeah.
10,
They were there,
12%.
but
They
didn't
were
do
there,
very
but
much.
it. Whereas the Jaguar was 50%. It was 500 horsepower from the electrification and 500 horsepower from the engine, which huge achievement to integrate those two powertrains. And I think from memory, I think something like 7 or 8 prototype cars were built. At least 1 or 2 being finished to full production standards, and they were glorious things, glorious. And I think what happened really is and who knows what might have happened if history was done differently. But I think fundamentally, Jaguar's sort of marketing people looked at that and said, well, you've got to, I think they worked out they had to sell maybe 500 to sort of recoup their money. And
Yeah.
and they simply got nervous about, is that possible? And in fairness to them, if it wasn't possible,
Unlikely.
you were going to lose an awful lot. So they sort of pulled the plug before they were too deeply into it. And of course, history's gone on to show that Porsche sold 918 of the 918, and I think there were more than 1,000 Ferraris.
Yeah.
So,
I've got a couple of questions on that powertrain and also that sort of topic of those sort of hybrids. If you take a 500 horsepower combustion engine and a 500 horsepower EV powertrain and you put them together, my belief is you don't get 1,000 horsepower, or that's not quite how it works.
you will, more or less. What you find is that, and what the world is sort of actually catching up with now, is that battery and electrification can't sustain the full performance for very long. So when you certify an engine, and so every car out there, if you're a car manufacturer and you claim in your adverts that your car has 500 horsepower, you have to prove that to the authorities. So when you do your type approval, and so for all the vehicles we're involved with, the type approval, the regulatory body come here, and they want to see all of the certification for our dynos and the calibration and the rest of it, and then they will witness power tests, and you have to be within, I think from memory, 2%. And when you power test that engine, you don't just flash it up to, you put it up and I think it holds it for 10 seconds or something. So they have to witness that, okay, for 10 seconds it's held 500 horsepower. What you find with a 500 horsepower electric motor is that it will flash up to 500 horsepower, but then in that 10 seconds it will decay. I don't know how much, but certainly a significant amount. Yeah, potentially tens of percent sort of thing, or 10%, let's say. So, and simply, obviously the as all of the internals of the thing become hot and the back EMFs and all the resistance changes, then so you end up. So I think you end up a little bit. I think maybe that's where some of that has come from. In that first instant, if you like, you will have 1,000 horsepower, but 10 seconds later you won't, because although the engine will sustain its performance, and so when they validate electric cars at the moment, they don't have that regulation, but there is sort of discussion about, is this really, should there be some average of the power over the 10 seconds or whatever? It's you just currently have to demonstrate that it.
Right. So what happens is, I guess, if you apply that into like the real world, if you're trying to do top speed for a long time, and if you had, I don't know, 500 plus 500, for a short period of time, you'll have your full 1,000, very short, and then you might have 900 or 950 or something for 10 minutes or so.
Yeah, so it will tail away a little bit. So you sort of need to get your full speed running on your first lap, really. So yeah, there's an element of that, and I think, but again, as the industry so the mainstream industry anyway, which is quite different to what we're involved with, I think, adopts electrification and understands electrification better, then I think, there's no escaping that there's a whole set of type approval regulations which are based around internal combustion engines and have been for 100 years, and at the moment they've just been sort of shoehorned into a similar sort of set of stuff for electrification. I think as more time goes by, those regulations and type approvals will change and modify to be more appropriate for electrification, rather than just sort of trying to approve a thing over here with a set of regulations designed for a different thing over here.
Is there a sort of ratio? Because hybrid powertrains bring a lot of benefits and different things to the experience, but is there a sort of ratio of like combustion engine to hybrid that you quite like for like I don't know, high performance road car? Or because we see a big variety.
I don't think I could say there's a kind of sweet spot that we've sort of seen and feel like that's, or at least I certainly have to think about that question a lot more. I think, to a very large extent, it's what you're trying to achieve with it. Now, the Bugatti is the best current example.
Yeah.
But, the Bugatti has 1,000 horsepower from the V16 and 1,000 horsepower from the electrification. That's sort of, I believe Bugatti was somewhat driven in that direction because the last Chiron, I believe, was something like 1,600 horsepower.
Yeah, something like that.
Just from the engine. So, and I think the first Veyron was 1,004, I think. So,
yeah.
So in their kind of 20-year history, Bugatti started at 1,000 and then went, 1,200, 1,400, 1,600. And I think it would be very hard to sell a Bugatti where you then rewound back to 1,000. So sort of the next step in Bugatti's evolution, I think, was always going to be upwards of 1,600. And which again, in the type of vehicle they're selling to the customer buying that, I think that's important. So, but alongside that, Bugatti wanted to lose the turbocharging and make the engine more of a centerpiece, if you like. So I think the previous W16, and that configuration of engine, we say to everybody, has been hugely successful for VW. Hugely. Very few engines, because effectively it started as the VR6 30-something years ago. Very few engine architectures can sustain such a long period and so many different applications. Obviously, it's W12 in the Bentley.
Yeah.
So hugely successful, but very much a turbocharged engine, which doesn't lend itself to normal aspiration, and very much something which is targeted towards performance rather than beauty, perhaps. I should say. So in the new era, Bugatti wanted to move away from that. Wanted to make the engine, the sound and the look and the extravagance, a real sort of USP for the car, but nobody was about to do a 2,000 horsepower engine.
Yeah.
So actually, that 50% hybrid split makes perfect sense there. 1,000 horsepower is about the most you're going to get from a normally aspirated engine that makes a great deal of sense in a road car. So therefore, you need the same again of electrification to hit your big power target. So I think for Bugatti, that big 50% is driven by the ultimate need for performance and the desire to move to a normally aspirated, perhaps more inspirational engine. But then if you look at the Valkyrie, which had 150, 160, I think, then it was there for very much a different reason. It was there in a large part of that actually was to help with the gear changes, to speed up the kind of gearbox lay shafts to be a perfect match when you're trying to and then it doesn't have a reverse gear, so the motor provides reverse and kind of some assist off the line and bits of fill in here and there. So kind of the motor on the Valkyrie was doing a very different set of things to on the Bugatti, and I think that's what drives some of this big split you see. It's what is the end objective from the hybridization.
What was it like developing that engine, like the Valkyrie engine, and trying to get it compliant? And I guess this is rolled onto future products and whatnot, but what was that?
So the Valkyrie, I guess, certainly was a kind of pivotal moment and say kind of introduced the hypercar years for Cosworth. Go back to what I was saying about the 177. We'd seen this vision of what a future might be like if there was a marketplace for those sort of engines. But it was the arrival of the Valkyrie that really made us think, what, we can actually pivot our business towards this marketplace and become what we are now, which we see as a product business. We're not a consultancy, really. We're a product business, albeit that the products are very, very high value, very, very low volume. They are still production engines. And I say that meaning that, number one has to be identical to number 100, has to be identical to number 200, if that's the last one, sort of thing. So it's the Valkyrie that kind of enabled us to sort of really turn our business towards this thing that we'd seen this little window of earlier. And so from the very beginning, we knew it was kind of potentially pivotal to the business. It was certainly, so it arrived to Cosworth from Red Bull, and we weren't aware of any Aston Martin involvement for probably a year or so. So initially it was Red Bull came to us. We'd had quite a long association with Red Bull supplying engines in F1, and so we kind of both organisations had people that knew each other. So they came to us, and the question was initially, is it possible to make a normally aspirated? It wasn't 1,000 horsepower initially; it was 950. Is it possible to make a normally aspirated 950 horsepower Euro 6 compliant engine? And that was the question, and no real suggestion of what it was for or what. So we kind of went away and scratched our heads. It landed. The question for us landed a very good time because we had spent quite a bit of effort in the previous couple of years investing in and investigating combustion. So combustion simulation, and then quite a lot of engine testing to try and correlate our simulation to real world results. So we, if Red Bull had come and asked us that question 2 years earlier, we would have been in a much less good place to answer it. But we've done enough work around combustion simulation and test and correlation that actually we felt it was possible. It would be lying if we said we knew exactly how, but we felt that it was going to be possible. We looked at the bore size we would need and the valve areas and the sort of tumble ratio and these sort of things, and we felt it should be possible. The actual mechanics by which we were going to do that was not clear to us, but that's kind of how it started. We kind of went back and said, well, yeah, we think it is. And then there was a bit of a lull, say, for maybe a year or so, where I guess Aston Martin and Red Bull were getting together. So then when it came back to us, it was at this point, clear that it was going to go in this Aston Martin sort of halo car, with Adrian designing it. So this is the point at which we were kind of introduced to Adrian, and really it kind of there was certainly some. I remember one, probably the most sobering moment in the whole thing was we were summoned to a big meeting at Aston Martin. Andy Palmer was CEO at the time. And so we were summoned to this big meeting at Aston Martin, and there were certain elements saying it just isn't possible. And, you're wrong, Cosworth. And, but sort of, the program had gathered enough momentum that that it was going to happen one way or another.
Yeah.
So it was kind of uncomfortable. We were in this meeting with elements of Aston Martin saying, we don't think it's possible. We think you've miscalculated. And us saying, well, no, we think it'll be okay, but we acknowledge that it's pretty hard. And I do remember Andy Palmer saying, well, we're betting the farm on this. If you're wrong and you can't deliver this thing, then we're going down the tubes. Frankly, you're coming with us. which was fair enough, but quite sobering that evening. Yeah. So we kind of knew, this is going to be. And he was right. In fairness, if we hadn't have delivered that, by this stage they'd sold half the cars. It was a huge public thing. And if we had have failed to deliver a car that could actually be type approved and sold for the road, then he's right. We probably all were going down the tubes. But nonetheless, being told that.
Yes.
So that was quite a sobering moment. But obviously we went on. You've probably seen stuff about how we approached this with a mule engine. And that, again, I think was quite a key thing in our sort of understanding of how we would approach it. Obviously, to get to a running V12 from scratch is a big, long mission. It's typically sort of 13 months or so to go from blank screen to a running engine, 14 months maybe. And what we did not want to do was we were doing all our combustion simulation, which was telling us, we think this is going to work. But you have to approach simulation in the same way as any other engineering tool. Really, it's still just an engineering tool. It might be incredibly sophisticated, but in the end, the proof's in the pudding. You need to get to metal. You need to get to hardware as soon as you can to actually prove it. Because however good simulation is, and it is immensely good, we very rarely get any surprises. But you always have to have in the back of your mind, in the end, it is just a tool.
Yeah, it might not quite.
It might
have
not
everything.
Be So we were very keen not to wait the sort of 13 or 14 months before we had a running V12 to establish whether our simulation was correct and we could meet emissions. So that's where we kind of lit upon the idea of a mule engine. Now, that per se is nothing new. Both ourselves and everybody else involved in Formula One had run single-cylinder engines for years, so we were very familiar with running single cylinders.
Oh, so you just do one cylinder?
Yeah.
Oh, okay. I didn't know that.
Yeah, so in Formula One, that's pretty common. You would just do a single cylinder because, it's you can get there much, much quicker. And if you just want to, if you want to change piston ring or whatever, you've only got to get one. So it just allows you, and certainly at the time we were involved with it, then cost was an issue, as is now, in fairness, with the cost cap. So it's a lot cheaper to do your development on one cylinder than it is on multi-cylinder engines. So single cylinders were quite common as development tools, but which is all fine in motor racing, but in the road engine world, they're not really applicable because everything is driven by the catalyst. So in the road engine world, for a V12, in a V12 you'll have 4 catalysts. So you'll join up sort of 3 cylinders per catalyst based on firing order and sort of so and that catalyst is obviously the thing which the speed at which you heat it and its performance, etc., is the thing which delivers you emissions or doesn't deliver you emissions. So that is the kind of key part of. So if you want to run a mule engine, you have to run it in a fashion which mimics the real engine behavior with the catalyst. So if you have a single cylinder, it's kind of useless. You just put the catalyst on the one cylinder.
At least
that's
three.
Not how it actually, exactly that. So you have to do 3 cylinders. And that's what caused us to think, well, we've got a 4-cylinder engine, which actually harks right back to the CX-75. It was so when that program was cancelled, there was some hardware left and some engines that we'd worked on, done other things with, and we picked one of those straight 4s and said, well, let's blank off 1 cylinder, do a 3-cylinder crank, and do to do a top end, which the combustion system has to replicate what you're going to do in the 12-cylinder. So effectively, we took this 4-cylinder engine and we made it into exactly a quarter of the V12. So it had the right bore-stroke ratio. We did a new cylinder head for it, which had exactly the combustion systems, so the valve angles, the injector positions, etc., etc. But all of the ancillary parts around it, the crank bearing sizes, that didn't matter. We had a standard pump package on it: the water pump, the oil pump, the scavenge pumps, the centrifuge. So we didn't have to do any of that. So by doing that, we were able to get this 3-cylinder mule on the dyno and running in about 6 months. So we ended up with kind of 7 or 8 months of running the mule before we ever had to fire the V12. And so, we actually discovered very quickly from running the mule, yes, we can meet the emissions, which was great. So we were then comfortable. Okay, we can press ahead, launching, casting tooling for the V12 and all the rest of it. Equally, if we had have not met emissions, we had have had an issue, then you've bought yourself 7 months in which to fix it before you're committed to delivering. So, and then we had all sorts of spin-off advantages that we didn't really think about. I mean, hindsight pretty obvious, but we just didn't think about them. So, you obviously have to do a lot of calibration on your mule to meet emissions. Well, then actually, when we ran the V12, we'd already done that base calibration. You just multiply it up by 4. So instead of having the first 6 weeks just doing base calibration, maybe there was a week of just porting what we'd done on the 3. So that's where that kind of methodology came from, and we really latched onto that as kind of it being a great approach, and we've done that every time since. Did it on Gordon's engine, and then with the V16, of course, a quarter of it's 4 cylinders, so we used the whole the whole thing.
Okay, as someone that doesn't know, I don't know very much about this. When your company is saying very vertically integrated, you can do everything. When you have to design a new V12, my brain goes, well, surely you just put your requirements into a model. It comes up with loosely, these cylinders, this size, blah, 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 blah. And then you basically can you not just hit print and make an engine and then go with that?
Yes. If only.
What are the main problems? Why can't you just make a new 12 straight away, or a 3 even?
So the kind of, so much of it is in the nuancing of what you want from the end result. So if somebody else came to us and said, we want a 6.5 litre, 1,000 horsepower, high revving V12 to go to 11,000, then for sure we would use some of the technology we learnt on the Valkyrie, but I guess that isn't really how it. So, when Gordon arrived with his engine, I think Gordon was very shrewd in that. Obviously the Valkyrie at the stage was 1,000 horsepower. The Mercedes Project One was 1,000 horsepower. I guess Bugattis were already more than that, and so it becomes a real sort of arms race. And so I think Gordon absolutely did not want to produce a car with 1,200 horsepower. So to avoid that comparison, he approached it as saying that he wanted to bookend the analog supercar, Hypercar, and what he sort of laid out was that to most people, the Lamborghini Miura was the first supercar, and certainly a very analog device. And the T50, again, is a very analog car. And as I'm sure you know, it's 3 pedals and a stick shift. There's no paddles. It's sort of it's very, very analog. It's not got any active suspension or. And this was a major part of Gordon's kind of philosophy. So he wanted to, as he described, bookend this phase. His feeling was that probably there won't be a more analog hypercar than the T50. The next one will have paddle shift and
Yeah, maybe
factors. So
hybrid or whatever. Yeah.
yeah, so he was kind of saying, I want to bookend this era, which I think was a really nice pitch. And the Lamborghini Miura had a 3.9 litre V12. So when Gordon came to us, he only really had two specifications. It was that it's a 3.9 litre engine to match the Miura, and that it should be the highest revving production road engine ever. Now, of course, we've just done that. We thought with the Valkyrie at 11,000. So it was like, oh, God, we made a rod for our own back there. It's sort of we had to go one better than 11,000, and Gordon certainly had in his mind 12,000 was a nice number.
Yeah.
So really, sort of 3.9 litres and 12,000 was his going in point. And if you then work back from that, the engine that you get, and even the combustion system, is very different to the Valkyrie. So the Valkyrie, very big bores, 6.5 litres, and those very big bores are very hard to meet emissions with. So on the Valkyrie, we have some really complex charge motion devices to provide. What you want for emissions is obviously to light your catalyst as soon as humanly possible, and for that you want very fast combustion, and so you can throw a lot of heat down the exhaust, and for that you need lots of turbulence within your combustion chamber, which is exactly the opposite of what you want to deliver 1,000 horsepower at high revs.
Yes.
Aspirated. So as you can imagine, for that you want really nice clean flow and a sort of nice barreling into the chamber. You don't want all this random turbulence. So you've got these two very opposite requirements. And in such a big bore of the Valkyrie, we achieved those two sort of not mutually exclusive, but certainly directionally opposite objectives by having twin spark plugs and a lot of active charge motion devices. But then doing Gordon's engine, only 3.9 litre, the bores are much, much smaller. And so we didn't need that complexity of combustion system. And it just has a single spark plug. But then you've got a rev at 12,000 RPM, which gives you a different set of... So say if anybody ever came and asked for the same thing, then there would probably be more similarity. But in our experience, everybody has, say, those two engines are normally aspirated V12s, but totally different in terms of I'd say totally. Obviously, what is the same is the approach and methodology. That is the thing that is a continuum through everything Cosworth's ever done in my time, certainly. That we have developed processes and methodologies and approaches and say sort of capabilities, and we apply those in a fashion that we're now very comfortable and confident with. But what you're actually applying them to, does give you different results, because I say that's the fact that two engines got 12 cylinders, their characteristics and their scale is very different, and that drives a very different end product.
Is emissions the hardest part?
Yes, I would say emissions is extremely hard and becoming harder. I think the next generation. So say emissions is all about lighting the catalyst. So catalysts do an absolutely incredible job and mop up, the vast majority of emissions.
Yeah.
But only when they're at full temperature, which is, I'm going to say maybe 800 C or something. So if you look at the kind of emissions versus time or distance for an engine, it is literally the first 30 seconds where the vast majority of so on your test cycle, which I think is maybe 20 minutes driving on a rolling road, it's the first 30 seconds where the vast majority of the emissions bleed through before the catalyst is alight. So almost everything you're doing within emissions work within an engine is to reduce that time, to light off the catalyst sooner. And ultimately, and up to Euro 6, we're all trying to do that with the combustion system within the engine. Ultimately, though, you can do that by other means. There's electrically heated catalysts where you have, and in some respects, you sort of think, well, crikey, that's a lot easier than and that's sort of a little bit, I think, where the industry, certainly at the kind of end of the industry where we're involved, is likely to move, because it is very hard, particularly to get such a big capacity, high revving engine through emissions. But I say, in the end, all inverted commas, all you're trying to do is light off the catalyst sooner. And actually, there potentially comes a point where you say, well, you know what, it's much better to have an active catalyst, electrically heated catalyst, so instead of trying to have a combustion system which lights it off another second faster, let's put an electrically heated element in there, and then you absolutely it can be full temperature before you even fire the engine.
That makes a lot of sense to me. I guess that's much easier in a hybrid powertrain.
So it's much easier there's all sorts of complications and reasons why they're not on every car in the car park. As you say, you've got to have 48 volt bus. There's not enough power you can get. So you've got to have 48 volts on the car. They require quite a big battery. There's a lot of quite thick cables, a lot of current goes through. And again, in the mainstream industry where everybody, all of the manufacturers do such a good job of getting the last 50 cents out of the sticker price of the car, then, to add, maybe a couple of $1,000s of electrically heated elements and a bigger is anathema directionally to where they want to go. But for the kind of hypercar space that we're in, then it makes a lot more sense. Say, the meeting the emissions is much harder because of the size and the speed of the engines, and then the cost and the existence of 48 volts is much less of an obstacle in the hypercar space. So I think now those elements in themselves require a lot of control and et cetera. So it's not just a sort of slam dunk, but it definitely, I think, kind of the hypercar end of the industry, I think, is going to move towards sort of externally heated cats rather than trying to make the engine more and more complicated to achieve that.
And does that also mean, because it's that first 30 seconds, it's getting the heat into the cats, and then you see people revving their McLarens on the street and burning straight through them. But does that mean if you're these hybrid engines, performance hybrid engines, where you can drive a little bit on EV and you can drive down the road on EV, presumably that if you're sort of constantly ticking in and out of engine on and not really doing very much versus electric, presumably your cats will drop in temperature or stay cold for quite a long time.
So that's a really good question, and you've observed a thing which is very difficult there, and the regulations. So I was saying earlier about regulations are beginning to catch up with the fact that hybrids and all electric vehicles are slightly different. That is one area where they have caught up quite a lot, and so because you could kind of say, well, that's great, isn't it? You only the emissions test to say is about 20 minutes. I think it's only about 20 kilometers, maybe less than that. I forget off the top of my head, but you sort of think, great, we just drive the whole thing electrically and then you've passed. But they are wise to that. So there's all sorts of regulations, which again, I don't know off the top of my head. There's much better people to clear, but
okay. Yeah. 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 Yeah.
how much insulation you've got around your exhaust system all comes into play.
How fast are you traveling on under EV?
Yeah,
I guess if you're going 100 miles an hour.
Exactly. Yeah. It's so it's that is a very complex kind of equation, and again, working with Bugatti on their system, which I say is the most complex because is this sort of 50% electrification, 50% hybrid, and the sort of the strategy for that, which is all under sort of Bugatti direction, and Bosch are the engine management partner and the electrification partner. So it's so we're more a watching brief in that than, but it is fascinating to see the different approaches you can take. And I know that there's some of the discussions have revolved around the engine being restarted 15 or 16 times in that little test window. And then say how long you can turn it off for, if you have to turn it back on, or the catalysts have fallen out of active temperature. So it's a big, complicated equation. But I think rightly so. It's I think engines have become incredibly clean. Really, it's somebody showed me a graph the other day of Euro 1 and what is Euro 7, and I think that's a really interesting thing. And it was, I don't know, it was probably Euro 7 was something like 50 to 100 times cleaner, I would guess, just from memory of this graph. And Euro 1 was only 30 years ago. It's sort of, and so engines have become, unimaginably cleaner in that period. And although, as engineer and the sort of business side of things, you kind of think, oh my God, we've got to do something yet harder and harder and harder. Actually, you stop at the end of it and look back and think, well, yeah,
it's pretty impressive.
It's a good thing, it was pretty impressive, and it's absolutely right that, and without legislation to force it, probably wouldn't happen because it's. So I think whilst on the one hand we kind of think, oh God, legislation's just so demanding. On the other hand, you look at what has actually been achieved, which has been driven by that legislation.
Yeah, it almost feels like to me, this period of time we're in now, maybe the next 10 years, that sort of period, when we're on this sort of phase out of maybe general cars moving to EV, and we're going to see more hybrids and whatnot, but we might also get a lot more renewable fuels. We could be in this sort of sweet spot of regulation and challenges of trying to hit these crazier and crazier targets. And then at the end, we still don't want emissions in cities and things like that. But if we somehow switch to using renewable fuels in these very expensive cars that don't get driven very much, which sort of makes sense, then you might be able to start, I'm sure you'll never be allowed to wind it back, but the total emissions becomes zero. And maybe you can just start making crazy engines again.
It's a great debate to be sort of coming into the public domain. I think the kind of if you rewind maybe 5 to 10 years ago, there was very much this sort of I guess perhaps at the beginning of when electric vehicles started to go from like 1% of the market share up to 5%, and people, then I think before that there was this sort of belief that they were somehow a silver bullet, and I guess Cosworth's view is that was never the case, but mainly because there's no such thing as a silver bullet. There's no one size fits all. It just so, and again, I think what's happening is that sort of now more debate like this, people are realizing that actually, electrification, like you say, undoubtedly clean at point of use, and that's a key thing in big cities, and that I think will only increase. But as we know, from a kind of cradle to grave emissions, electric vehicles are actually somewhat behind a conventional. So in terms of the manufacturing and the disposal of the batteries and such like at the end of it, and obviously depending on how the electricity is generated, the actual mileages you have to achieve are quite high before you're. And I say particularly if if the electricity generated is not green, then the mileages are really high before you enter that kind of neutral zone where electrification is. So I guess we've sort of always felt that that battery electric has its place, and say certainly as a cleaner point of use. But we've also felt that the internal combustion engine, because again, we're not talking about the 70s where maybe you were lucky if you could get 20% thermal efficiency. A good gasoline engine now is like 40% thermal efficiency. And it's very, very hard to make something as cheaply as you can make a mass production internal combustion engine, and to ever have an infrastructure where you can access fuel so accessibly. And certainly no fuel has the sort of energy density of remotely close to sort of liquid gasoline fuels. So we've kind of always felt that it's horses for courses. And I think what feels nice about sort of the current time, better than 6, 7, 8 years ago, is that it feels like there's now a kind of, as you say, a kind of big debate around this, and is less divisive. There's less sort of like you're either part of the solution or you're part of the problem. There's more kind of, let's look at this, and like you say, synthetic fuels. Yeah, they're obviously still expensive and quite slightly inaccessible for sort of the mass market, but in the hypercar world, they're not expensive proportionally, and again, they're very accessible because that operating area can effectively, potentially could deliver the fuel to your door.
Yeah.
So I think the kind of realization is coming around that actually, it doesn't need to be us and them in the kind of the electrification world. Actually, there's all sorts of different ways at this issue, and I think the kind of the hypercar space where it's not, hypercars are really nothing to do with transport. They're not about getting from A to B. They're very different to that. We often use this analogy. It's like sort of we all of us have a phone in our pocket which tells the time much more accurately than a $10,000 Rolex.
Yes.
But $10,000 Rolex it's their biggest selling time in history because it's a nice thing. It's if somebody's in the fortunate position of owning one of those, then it's it's a pleasure to have, and that kind of connection with the mechanical element of it, and I think it's the same with the hypercars. The hypercars, a big part of the appeal is that kind of visceral part of the engine. It's the sound, it's the smell, it's the vibration, and it's the looks. We work very hard to say, if the car going to cost $1 million, it better look $1 million, and that's sort of, we work very hard to make the engine bay, a thing of beauty, a work of art, and sort of that. I think people are kind of coming to realise that space won't really exist if it can't have an engine, and not many people don't want that space to exist. I think so. It's kind of so it feels like the kind of world is moving to a position where there's a kind of understanding and acceptance that actually we can have all of these things in the right place.
Yeah, and in this segment, the cars just don't get driven very much. It just makes no sense to be EV.
In reality, yes. In reality, some of the cars will do a few hundred kilometres in a decade.
Yeah, yeah, exactly.
Most of them a few hundred kilometres a year or a few thousand a year.
Yeah.
Some a decade. And some will do, we do always know there's a handful of customers that will use them as everyday cars. And,
yeah, they are outliers though.
They are outliers, that's true.
I sort of almost, I feel like, and I don't know whether you feel like this, I feel like right now is the era of Cosworth V12 hypercars. Because there seems to be this thing, and I've had this conversation with quite a few people from sort of different ends of it. Some sort of resto mod type people, some one hypercar manufacturer. That when I look right now, Ferrari F80 released. We know Porsche are going to come out with something at some point. McLaren have just done the W1. None of these manufacturers seem to be allowed to make the car that I feel like they want to make. Like, I don't truly believe Ferrari wants to sell its top hypercar as a turbo V6, and it's a similar sort of thing. Maybe looking back at like CX-75, like, yeah, you can make a crazy hype, but like, do the customers want it? I think the customers want the crazy, they want the exotic powertrain, they want to open it up, they want to see it looking amazing. Like, how do you think all of this fits?
I do absolutely think that in our minds, then the Valkyrie was the start of a new hypercar era. That I guess maybe people would say that the Bugatti Veyron was the first hypercar. Maybe I think opinions differ, but I guess for a long period, then I'm not sure. I'm not sure what broke that mold, but then I think the arrival of the Valkyrie has triggered a huge sudden interest and marketplace, and I don't know whether some of that goes back to things like COVID. I think lots of people I guess we were all just utterly, speaking personally, couldn't believe that COVID could ever have happened. How could this? If somebody had said to me a year before, and probably to most of us, oh yes, in a year's time, the whole world would be locked down by this thing that people won't be going to work, and it was just unbelievable. And then I think after it's happened, you're in that kind of like, well, if it could happen once, it could happen again. So I personally think we're too deep into the philosophy, but maybe people have kind of felt a bit more like, well, yeah, I need to do some of these things that I want to do and live for the moment a bit more, maybe. And then I think also they've become, they are works of art now. I think, in a way that maybe they weren't before. And I think, they're works of art, they're investments as well, I guess, and just things to be celebrated. To say there is, I think you've probably seen it. There's the video of the T50 being driven through the Pyrenees, and just the
Yeah.
bark of the exhaust off the mountains and things. It's sort of, it isn't something you hear every day, and it is for, I think, most people with a little bit of petrol in their veins. Anyway, it's a glorious thing and a thing to be celebrated. And we're certainly very fortunate that we were there with the Valkyrie, and then I believe we did a really good job with that, and so we put ourselves in the position of it being natural for Gordon to come and talk to us about the V12, and then obviously the Bugatti arriving was a sort of incredible thing. So it is the most incredible time, certainly in my whole experience at Cosworth. I feel like we're more than any other time in the history of I've been here, this is our sweet spot. This is our moment, and I think it's really interesting to look at sort of social media, which lots of people have shown me stuff that before Valkyrie, I don't think I've ever seen anything negative about Cosworth, but before Valkyrie, it was a bit like we were a favourite uncle. Remember the Cosworth Sierra? Oh, that was great. Or remember back when? But post Valkyrie, it's kind of like these guys rule the world. It's sort of, and I think that's a really nice thing. As a company,
That's cool.
We've worked very hard to put ourselves in this position, and it's fantastic for the world to be kind of celebrating what we're doing. So.
And why do you think? Yeah, why do you think someone like McLaren hasn't done the high? Well, I mean, they do have a modern V12 in the 12 cylindry, but they're hypercar. Why have they not done a V12 in that? Do you have any thoughts?
Yeah, I don't know. I guess maybe in their positioning of Ferrari have got such an incredible array of vehicles, because I guess they have the V12 in the Purosangue, I think.
Yeah, and they've now got the new, like the 2-seater GT. It's called the 12. It's basically called the 12 cylinders.
Yeah, it looks a little bit like a Daytona.
Yeah. So that's a V12.
One of my all-time favourite cars. So I don't know. They've got such an array of vehicles. I don't profess to know kind of how they position them in and why the latest
why it's like that.
Ferrari successor is not a 12. Yeah, hard to know, but
it's sort of
obviously the if you look at a pure performance perspective, and maybe this is where they're coming from, like say the 12 cylinder or whatever is not so much out and out performance. But for the ultimate out and out performance, then it would be the right way to go, because obviously the weight of a V6 turbo is so much less than the V12, and you just can't ignore the efficiency and effectiveness of a turbo for full performance. It's all that exhaust all that heat that you're just throwing down the exhaust in normal aspiration, which you're using in a turbocharger. So for out and out performance, it's pretty hard to beat the turbocharged engine. If your target is perhaps a bit more character, such as the 12 cylinder, then the 12 cylinder NA fits better. So maybe it's as simple as that. It's the difference between the sort of more character vehicles and the more ultimate performance.
But, yeah, I wonder if the big manufacturers, and I'd put Ferrari in that category. Like Bugatti doesn't make very many cars. No. Of all these
Ferrari's in a slightly
bespoke category
space of its own. Yeah,
Ferrari makes a lot more cars. Porsche makes a lot more cars. So they have to have their average emissions and all that sort of stuff. So they fall under different rules. And I personally, I would love for like Ferrari and Porsche and all these companies to like just make make like a slight like offshoot company that is its own company, but it just makes the crazy, crazy, crazy stuff. And then you don't have the same rules.
Yeah, that's called Cosworth.
Yeah. No, it's an interesting one. And there's so many cool projects coming out now. And I see Cosworth engines in a lot of stuff. And they sound pretty sick. If you had to design an engine for a road car, where would you lean?
I think I'd say it's driven so much by these say the space that we operate in. Say the engine is driven so much by the end game. Yeah. Say for Gordon, it was very clear. I want to bookend the kind of, so I want 3.9 litres and 12 cylinders, and that drives you that way. For Bugatti, I know Bugatti have this thing of like, if it's comparable, it's not a Bugatti.
Yeah.
So
yeah,
they had to have something other than
crazy,
12.
Yeah.
And so kind of, I think does 16 cylinders in an absolute in any absolute measure, is 16 cylinders where you would go to design an engine?
Yeah.
No, of course it's not. I don't think that. But is it where you'd go if you want a thing that everybody is going to say, "Oh,
what is this?" Yeah,
it's and I've said this before, but I think it's in its tiny way, the world is a better place for having these engineering marvels out there.
Totally.
And that. So I think it's great that the kind of, nobody actually comes to us and says, what would you say is the most sensible engine? They come to us with this is what we want to achieve.
This is the
we
statement.
Want an engine that nobody else has got, or we want to book.
You're like, no, we've got this one. We've already done. Yeah, it's perfect.
Yeah. So it's so the kind of what would be the what would be the optimum isn't really a question that anybody asks, which is probably a nice thing.
Right. Well, I normally wrap these up with 5 questions. Do you have a most memorable driving trip or journey?
I would say perhaps I have an old 1972 Bristol, and I've done a bit of classic sort of road rallying in that. And a few years back, I did with my great friend John as navigator, Land's End to John O'Groats, if you're familiar with that.
Mm-hmm. Yeah.
We did that in the Bristol, and that is most definitely seared on my mind.
I was about to say, how reliable was it?
Oh, actually, no, the Bristol was absolutely bulletproof reliable. It was. We actually ended up ridiculously. I think there were about 100 entries, and we won our class, and I think we're like 13th or something overall, which was far better than we ever imagined. And fundamentally, those things are won or lost by the navigator. So I can take very little credit for this. John said left and right, and I just went there. But the bit where we moved right up the leaderboard that always sticks in our mind is the last night, where basically, from memory, you would start driving. I think we started driving at like 10 in the morning, drove all through the day and all through the night, and ended up in John O'Groats at 11 o'clock the next morning. And that last stint was just hours and hours and hours in the snow and the cold.
Oh, wow.
And we realised that we went from like, back midfield rocketing up to 13th in that period. And I swear it's just because in the Bristol we had big comfy leather chairs, we had the heater on.
Yeah.
If we finished with a map, we chucked it over. And then there was all the poor people in a Triumph TR4
Yeah.
where the snow was coming
in the elements,
freezing cold, and and I think people were just beginning to sort of fade away.
Attrition.
We were all attrition just came, and the Bristol came into its own in that last 6 hours. So that sticks in my memory.
Yeah, I mean that sounds quite memorable. If you could only drive one sports car for the rest of your life, and you've got like a £5,000 thing on the side, what would your sports car be, and what would maybe your runabout or family car or whatever be? My
sports car, I think I'd have to say a Ferrari 360.
Oh, manual.
I'm not fussy, really.
Sure.
Fussy. My runabout on the side. I'm a huge Italian car fan, and I'd maybe go for. I don't know whether you get one for £5,000, but possibly you could. Fiat 124 Spider. I'm going to go for.
Oh yeah. Nice.
Probably the sort of like first year of the modern ones, which maybe have got down to that price.
Yeah. What do you think is the most undervalued car at the moment? What should be worth more? Obviously, everything with the Cosworth engine in it. Other than that,
or Bristol 411, I would say. Bristol 411. Well, you know what? I am absolutely the wrong person to ask that of, because every car I have ever bought, I know a couple of people that have bought cars. We bought cars several times and hung on to them for 5 years, and theirs have doubled in price and mine have lost 50%. So I came to realise some long time ago, I think maybe some of my early cars, I convinced my wife that kind of like, well, it'll be an investment. For the last 15 years, I've completely said, to be clear, this will not be an investment.
Yes.
So I don't think I can spot those cars so well.
Fair enough. What is the most interesting car to you at the moment? That could be technology, what you're Googling, what you're looking up.
I think, perhaps slightly left field here. Are you familiar with so again, one of my teenage absolute car I absolutely loved was the Lancia Monte Carlo. Are you familiar with the company that's doing a thing called an Evo 37?
Yes,
which is
Chimera.
That's right, Chimera. Yeah. Kind of a reimagining of the 037 rally car loosely based on a Monte Carlo chassis.
Yeah.
Those I think are stunning.
Yeah, very cool.
I had the opportunity to be at Quail and Pebble Beach a few months ago, and they had a big showing there, and I think they're just fantastic. That's a thing that's really caught my imagination.
It's very cool, and I think that's quite a hardcore car. Everything I've heard from people that drive them is they're pretty serious and involving.
And again, I think great they've managed to make a business out of that.
Yeah. Totally.
They sell for a lot of money, and hats off to them. That's quite I think it's quite brave to go into deciding to do a car like that from a business perspective. But looks like they've done very well out of it. So
it's very cool.
So nice to see. encourages I think that succeeding in business in those kind of things hopefully encourages somebody to do whatever the next one might be.
Yes,
So
yes, and we're
it's really
seeing a
important
lot,
that they.
which it's easy to get overwhelmed by every new resto mod or whatever these days. But I get to talk to a lot of the people through this sort of thing, and most of them are really passionate about it. And that's, if they sell some, great. Hopefully they continue. But these people are seriously enthusiastic, and it's pretty cool to see. Right, final question. 5-car garage, unlimited value. It's got to fit into your life loosely. So I don't know, if you need a daily, you've got to have a daily.
Oh, crikey. Well, I'm going to have a Daytona. So I've always loved the Daytona. I'm going to have a modern Maserati Quattroporte, because I had one of those, and I think they're vastly underrated. I'm going to have then the reimagined 037, as we just described. All looking very Italian so far, isn't it?
Yeah.
I'm going to have the Bristol, actually. I have to have the Bristol.
Okay, Bristol. So you've got 4 now.
I'm going to have my last one. Well, maybe I will have an Aston Martin V8 from the kind of 80s, the X-Pac V8 Vantage from the 80s.
Nice. Yeah, I like them. Well, that's a good bunch of cars. Well, thanks very much for coming on the podcast.
Pleasure. It's been very interesting. So I've enjoyed it.